So, Laura, since the centers of these distributions are close, can one conclude that there is no difference between these two cities with regards to monthly temperatures?
No, you can't conclude that since Raleigh has a greater range. There was obviously a difference, and Raleigh seems to be colder.
There are definitely colder months in Raleigh. I wouldn't say that Raleigh overall is colder, because I think some people might interpret that as the median or the mean. Okay. So, but mostly I agree with you. No, the center tells us nothing about how variable temps are across the year. Raleigh has a lot more variability. Okay? So if you go around saying that Raleigh and San Francisco have similar medians, you're really leaving out a great deal of the picture. Raleigh gets a lot hotter than San Fran and a lot colder than San Fran. So even though the medians are about the same, there's a big difference in variation. Okay, Glenn, which city has more variability in its monthly average temperatures?
Raleigh.
Raleigh, easy. Jeffrey, what is the highest monthly temperature for Raleigh?
The highest is 78.
78 degrees. Yep.
And the lowest is 39.
And the lowest is 39.
The difference is 39.
And the difference is 39. This is a statistic called the range, something that we expect you to know, at least for Chapter 5. Okay? That's the spread of the entire data set. Good. And Savog, the highest monthly temp for San Fran?
65 degrees.
65 degrees. Okay. Significantly cooler. And that's actually in September. And how about the lowest? 49 degrees. And that's both Jan and December. And the difference between those two? 16, yes. So the range for San Francisco is less than half of the range for Raleigh. I would conclude that is a big difference. Any questions on the first page? Okay, so we just learned about a statistic called range. It's simple, maybe not that useful because it is simply the max minus the min, but it can be used to some degree of success. There's another measure of variability. It's called interquartile range. Did I show you the College Board website yesterday?
Yeah.
Okay, so this is related to that. On the College Board website, they reported the middle 50% of SAT scores at a particular college. That's corresponding to interquartile range. So that's the difference between the upper quartile and the lower quartile. The lower quartile is the 25th percentile, which means that about 25% of the data falls below it. The third quartile, no surprise, third 3/4 is the 75th percentile. In other words, 75% of the data, or about that, falls below it. It's like percentile rank. When you receive your test scores, don't they provide percentile rank? Okay. So I think you all have an understanding. If you get a percentile rank of 90th percentile, that's very good. That means that you scored better than 90% of test takers. So because you're taking the difference between the 75th and the 25th percentile, the interquartile range is the spread of the middle 50%, 75 minus 25. To find the lower quartile, what you do is you find the median of the lower half of the data. So half of a half is a quarter. And for the upper quartile, you find the median of the upper half of the data. And as I wrote here, there is not one standard for finding quartiles. Just like there's no objective definition of an outlier that everybody agrees to. So your calculator might give you a different answer for a quartile than Excel, and there's probably other answers that you could get. And as I was going around, either in this class or other classes, some students were asking exactly how to find the quartile. For example, do I include the median numbers in the halves or not? And that's one of the areas of debate in statistics, just so you know. What's more important to me is that you have a understanding of conceptually what does a quartile mean. So if it's the lower quartile or the first quartile, that you have an understanding that about 25% of the data falls below it. Okay? So let's find the lower quartile using one method. They're asking us to list the observations that fall below the location of the median. So in other words, the coldest half of months, or the coldest half of the year. I got my data sorted. So it's easy. 39, 42, 43, 50, 51, 59. That's the bottom half for Raleigh. Then you find the median. How many numbers do you have?
6.
6. Is 6 odd or even?
Even.
Even. So the median is the average of the
Third and fourth.
third and fourth. The difference between 43 and 50 is 7. Cut 7 in half. It's 3.5. Add 3.5 to 43. There you go. 46.5 degrees Fahrenheit. You will see me and others denote the first quartile as Q1. So be aware of that. Now we're going to find Q3. We list the warmest 6 months in Raleigh. Okay, so 60, 67, 71, 74, 77, 78. Just like number 6, the median is going to be between the third and the fourth number. Since there is no middle number, we take the average of the middle 2. I would say even that is a convention. The difference between 71 and 74 is 3. 3 divided by 2 is 1.5. Add 1.5 to 71. 72.5 degrees. Okay. So now I know that in Raleigh, North Carolina, in 25% of the months, it's going to be warmer than 72.5 degrees. Does that make sense? Okay, that's how you use the quartiles. And in 25% of the months in Raleigh, it's going to be colder than 46.5 degrees. 8, verify that 1/4 of the values fall below the lower quartile. Okay, easy. Here's my lower quartile. I have 1, 2, 3 months that are below it. 3 out of 12 is 1/4. And similarly, we have 3 months that are warmer than the third quartile.
Bless you.
And then half are in between. 1, 2, 3, 4, 5, 6. 6 months are in between. In other words, 1/2 of values are. Good. Any questions on finding the quartiles? Okay, Krishna, I think you're next in line. What is the interquartile range for Raleigh?
50, 51, 57, 56, I'm sorry, 57, 60, 67, 71.
Okay, so when I ask for interquartile range, it's simply the difference between the third quartile and the first quartile, the upper quartile and the lower quartile. So IQR is Q3 minus Q1. 26, 72.5 minus 46.5. (26°F). That is the spread of the middle 50% of data. And Mara, is the IQR of Raleigh's monthly temps greater or less than the IQR for San Francisco?
Raleigh's is greater.
Raleigh's is greater. And is that what you would expect?
Yeah, because it has a greater spread.
Yeah, if you look at the dot plot, there's not just a greater spread between max and min, there's a greater spread in the middle as well. Okay. So range is only going to take into account the max and the min. But it's not just the difference between the max and the min that's more for Raleigh. It's also the difference between the middle half of the months is greater than the difference in the middle half of the months for San Fran. So IQR is, again, the spread of the middle 50%. Yes, Raleigh has more variability. In its temps. Not just max minus min, but also in the middle. Okay. Also think about the SAT scores. If a school reported just the range, they could have a student who had an 800. That's all it would take, is one student. And then maybe they admitted a student who got a 400. So if they go around reporting that the range of their SAT scores is 400, I don't think that helps anybody. Would you agree? It's not useful that there's a 400-point spread at the school. Yeah, like that's just the highest and the lowest. What's going on in the middle? Okay. So this is why colleges report the interquartile range. Now I'm just going to make up numbers here, unless you remember the ones from yesterday, which I doubt you do. So let's just say that the 75th percentile at a particular school was 700, and that the 25th percentile at a school was 550. That's more useful information. That tells me the difference between the 75th percentile and the 25th percentile. In other words, there's a 150-point spread in the middle 50%, and that could be considered what are typical students at that school. So it says the median, quartiles, and extremes of a distribution constitute its 5-number summary, so called because it provides a quick and convenient description of where the 4 quarters of the data fall. Before I get into that, though, what do you think is an advantage of IQR? So what you'll find when you're studying statistics is that there are options. You have options in how you graph data, like stem and leaf plot, box plot, histogram, dot plot, things like that, time plot. You also have options when it comes to statistics. For example, are you going to use the mean? Are you going to use the median? In this case, you have options about spread. Are you going to use the range? Are you going to use the interquartile range? Each thing has its advantage or strength and weakness or disadvantage. So I'll ask again, what do you think is the strength of IQR? Yes?
It shows us technical. It makes it so like, the outliers don't play as huge of an effect. Like you said, it could just not be one person on the 800 and everyone else was like the same things.
Exactly. The range could easily be skewed by one value. That's all it takes. And thus could misrepresent the distribution. The IQR is looking at the middle 50%. So it is eliminating or excluding the extreme values, and thus could provide you a more representative measure of variability. Okay? Does that make sense? So, know what a 5-number summary is. Minimum, lower quartile, median, upper quartile, maximum. You can think of this in terms of percentiles. What's the percentile of the minimum? 0th percentile. Does that make sense? Because none of the data is below it? Okay. What's this percentile? Yep. What's this one? Yep. 50th. The median is also known as Q2 because of that. Then I think you get it. Yep, 75th. This. Yep. Now there's some argument about whether or not this should be the 100th percentile, because some definitions say that you should have 100% of the data below it, but how is that possible? I'm not going to get into that discussion. But just so you know, it's out there. Next in line, let's go to Unwan. What was the minimum temp for Raleigh? 39. Maria, the lower quartile? 46.5. Ethan, the median? 59.5. Teo, the upper quartile? 72.5. PG, the maximum? 78. The 5-number summary might seem simple to you, but I, and you soon enough, will learn that there's a remarkable amount of information that can be gleaned from it for any distribution. You can tell the spread of the entire distribution from it, min and max. You can tell the spread of the middle 50% of values, so like excluding the extremes. You can tell exactly where it's centered. You can also tell skew from it, okay, which you'll learn. The only thing, modes. Okay, that you cannot tell. The graphical representation of the 5-number summary is called a box plot or a box and whisker plot. And that's the last part of this activity. And again, thanks, John Tukey. R.I.P. 2000. Thanks. So, John Tukey, very prominent statistician in the 20th century, very intelligent guy, PhD in mathematics. He came up with a lot of graphical displays that are still used today. For example, the stem and leaf plot, the box and whisker plot, and as you'll see later, other things. Like he came up with an outlier test. So a lot of contributions he made. One thing I like about Tukey is that even though he was very intelligent, he had no qualms with coming up with simplistic ways. Maybe simplistic is a pejorative connotation, so I'll use simple ways of displaying data that are effective. And that was his bent, was on looking at the data, looking at pictures, not just observing the statistics. Okay, so we thank him for his contributions. The box and whisker plot is great for comparing distributions, as we are going to do here. So, it's very simple. As I said, it's a plot of the 5-number summary. It's one of the strengths of this type of graph. It's easy to understand and easy to construct. That was another thing that Tukey wanted to do, was to be able to have a graph that didn't require a computer to draw. So, Raleigh, tell me, what's the min? 39. So that's where our left whisker is going to begin. What's the Q1? 56.5. 46.5, thank you. So maybe about here. The median? 59.5, thanks. So about here. Q3? 72.5. And the max? 78. Now we construct our plot. Left whisker extends from the minimum to the first quartile. Then you have the left edge of the box. The median also gets a vertical line, at least in the convention that we use. The box extends from the first quartile to the third quartile. And the right whisker goes from the third quartile to the max. Easy. Any questions on constructing a box and whisker plot? Some nun waved at me. Okay. I can tell a lot from this plot. I can tell that Raleigh and San Francisco have symmetric distributions. Why? Because the median is in the middle of the box, in the center of the box. Also, the whiskers are of equal length, or relatively equal length. I can tell exactly where the centers are. I can tell that Raleigh is a little bit warmer overall than San Francisco because the median is higher for Raleigh. I can tell obviously about the spread. Not only does Raleigh have a much greater spread overall, it also has a greater spread in the middle 50%. Actually, the middle 50% of months in Raleigh have more variation in their temps than all of the months in San Francisco. Okay? So there's more variability in the middle half of data for Raleigh than there is in all of San Francisco. So quite different distributions. Okay, I can tell exactly where the 25th and the 75th percentile are. So if I want to know what cuts off the bottom quarter or top quarter, I can do that. So a lot of stuff that we can tell from the box and whisker plot. And let me show you how to do it on the calculator. Fortunately, this thing can do just about everything that we study in this class, which is the main reason that I still use it, even though it's ancient technology, relatively speaking. So I just want you to know that the data does not need to be sorted in order for the calculator to create the box and whisker plot. You just need to have it in there, which you should have already if you were following along when we were sorting the data. As with the histograms, I go to second y equals. I go into plot 1, and I am going to choose this one. This one does not show outliers. Later we can play with the one that does. Okay, so select the second one on the second row. When you get to the type category, you have to go to the right. That's how you get to the second row. And then L1, that's fine. Leave freak at 1. As I said, box plots are great for making comparisons. So let's go into plot 2. Enter. Turn that on. Select the regular box and whisker plot. But this time, choose L2 for your X list. Guess what I press next? Zoom 9. Still don't know why it does that.
Yeah, it does that.
I think if you're in alpha mode or something, it does that anyway. Okay, so zoom 9. There you go. And you can press trace like normal, and it will tell you min, Q1, median, Q3, max, and then press down, and you get to the other one. Very handy. So I encourage you to become as fluent with this calculator as possible. Technology. It's great. And then our final question. Who are we up to? Lucy? Is that who we're up to? Okay. What aspect of a distribution can't you tell from a box plot? You can tell skew. You can tell something about where the data is concentrated. So, for example, if you had a box plot that looked like this, I can tell you that this is skewed to the right. I can also tell you that the bulk or the greater density is to the left of the median. So I expect that the histogram for this would look something like that. So try again. What's something that you cannot tell from the box and whisker plot that you could tell from a histogram? So many options. Teo.
Outliers
Okay, with this non-modified version, I agree with you from the outlier point of view. And I agree with you for either option regarding modality. Okay, you cannot tell anything about whether the distribution is bimodal, unimodal, multimodal. So know the strengths and weaknesses of your plots and of your statistics. Okay?